So we have two functions we're going to look at. We have f of x, which is negative x squared plus 5. And we have g of x, which is 3x minus 1. And so our first function operation is going to be adding. So f of x plus g of x. And when mathematicians use f of x plus g of x, they are lazy. They don't like that they have to write the x twice and that they have to put lots of parentheses. So they often write this as f plus g of x. That's like the shorthand notation. I don't know why they think it's better. All you do is you write one less x and you have less space, I guess. Yeah, so, but these mean the same thing, okay? All right, so here's our example. If we are doing f, would we write if these are the original functions? So we have f of x plus g of x. Is there anything outside the parentheses that needs to be distributed? Nope. So we really just have all of these different terms, right? Are there any like terms? The 5 and the negative 1? Okay, so what should I be writing first to put it in the correct order? Negative x squared plus 3x plus 4. Yeah, so to say it out loud, you would say f plus g of x. Okay. The next one is f of x minus g of x. And how do you guys think mathematicians write that one? F minus g of x. So what should I write? Yep, we're going to use the same f and g. Okay, minus 3x minus 1. Okay. Is there anything outside the parentheses that needs to happen? Yeah, the negative. So the first one can just be rewritten. There's nothing to do there. But the second one has a negative that we need to distribute. Are there any like terms to combine? 5 and 1. Okay. So if we put this in the correct order, you're close. Minus 3x plus 6. Perfect. All right, the next one is f of x times g of x. How do you think mathematicians write this one? F times g of x. All right, so if we go with that same example, what should we write? Same f, same g. Okay, so negative x squared plus 5, 3x minus 1, and how do we do that? Yeah, we FOIL it, right? So we have negative x squared times 3x, negative 3x cubed, negative x squared times negative 1 is positive x squared, 5 times 3x, 15x, 5 times negative 1 is minus 5. Are there any like terms? Nope. Is it in the correct order? Yeah, so it's done. Yeah. It's like you guys know what operations are. Okay, so we could have f of x divided by g of x, or let's say it this way, they could say f of x divided by g of x. They could write it either way. And then what would the mathematician way be? So they could say f divided by g of x, which looks pretty funky, right? Or they could say f divided by g of x. Ooh, that parenthesis was not very good looking. Whew. Okay. Pay attention when you do the problems because every so often they'll be like g divided by f. And they'll go backwards, so that could happen. All right, so what should I write for my example? And the nice thing about division is you're done. That was it. Yeah, wasn't that fun? Well, these ones we will go over a unit. This is called a rational expression because rational is like fractions. We'll go over a unit where we work with those a little bit more in depth, but for today, we're done. We call it good. Okay, so can somebody remind me what the word operations means in math? You didn't even wait for the question.
No,
oh, you have a question?
I have a question on that.
Yes, yes, yes.
Okay, for this, I was wondering if it's possible. Since 5 and negative 1 are, you can find them. You just write negative 5 up there.
You could, but you would kill a puppy because you would be dividing terms. Because this is an addition problem, and that's a subtraction problem, and you would be telling me that division cancels out addition and subtraction. So you can't do that. I mean, you could if you wanted to kill a puppy and get it wrong, but if you don't want to get it wrong, then you can't do that. Okay, Scott. Did you have your hand raised? When it comes to you, let me know. What does the word operation mean in math? Yes. Yeah, operations are adding, subtracting, multiplying, dividing, raising to an exponent, whatever. So when I say function operations, I'm saying how do you add, subtract, multiply, and divide functions. Do you guys like my division symbol? It was sloppy. So this is like you've done all this math before, you just didn't have this notation in the beginning of the problem. And so the only thing that's new today is this notation in the beginning of the problem. The rest of it you've done before. So let me give you a worksheet. Evaluate. So that's just like the activity we did. You're just plugging numbers in, or you could be plugging expressions in. So that should be fairly comfortable. Let's go ahead. We're going to look at like 11, 12 through 20. You're not going to skip them. You're going to do them. But I want you guys to look and just tell me if you're looking at a problem, is there any problem that's making you nervous or one where the notation doesn't make sense? How do you guys feel as you look at 11 through 20? Is there any sad? Is there any problem where you're like, nah, that's not like the example? 18? No, it just has an N, right? Just an N instead of X, but it's the same. Yeah. So what does this mean for 18 when it says G plus F? What does that mean? Yeah, so it means you're going to do G of N plus F of N. So you're just going to take the first one and add it to the second one. That's all it means. No, you're going to do all of them. Because I just want to make sure you guys are comfortable. Because we practiced 1 through 10 already. You're just going to do some more. What? No, you do. All right. So go ahead. Yeah, you tried. Good try. All right, go ahead and get started. I'm going to put some music on.